Hi, will you be able to find the area of the shaded portion if and only if the only given information is 8? That is, the length from here to here is 8. Welcome back to my channel. Well, this looks like an impossible mission, but the truth remains that it is very, very possible. So together, let's go down and find the value of this. The first thing we need to do is to analyze this diagram. Please, this is a rough sketch, okay? It's not drawn to scale. Now, but if you look closely at this diagram, you notice that there are three shapes. The first is this, a quarter circle. We have a quarter circle, okay? Then we have two semicircles. We have this, the semicircle, this, and we have this one as well. So we have two semicircles and one quarter circle. So that will go a long way to tell us how to go about this. Now, first of all, because we are looking for area of the quarter circle, is equal to 1 over 4 multiplied by pi r root squared. Okay, 1 over 4 pi r root squared. So the area of the quarter circle will be equal to 1 over 4 multiplied by pi multiplied by our radius is what? 8. 8 multiplied by 8, right? So 4 we divide this to give us 2. So it means that the area of the quarter circle is 2 times 8, 16 pi. Okay? So area of the quarter circle is 16 pi. So I'll write that down. So we have area of the quarter circle is 16 pi. Okay, now I'm going to clean this so that we don't get confused. But before that, if this is the diameter of the circle, so we have A, B, C. Now the diameter of this semicircle is from here to here, which is also equal to 8, because since this is a quarter circle, it means that AB is the radius of this quarter circle. Therefore, it should be equal to BC, which is also its radius. Now, since this is the diameter, it means that the radius of the semicircle is 4. So here is 4 and here is 4. Alright, so if we want to find the area of the semicircle, so area of the quarter half circle is half pi r root squared. Half pi r root squared. So this is equal to half times pi times 4 squared, because the radius is 4, right? Now, if we move forward, we will have that the area of the semicircle is equal to half times pi times 16. So the area of the half circle is equal to half times pi. Oh, so this we divide this to give us 8. So it's going to give us 8 pi. Is equal to 8 pi. So let me write that down. Yeah. So writing that down, area of the half circle is 8 pi. Now you can see that we have two semicircles, right? The radius of this is 4. Also, the radius of this is 4 as well. Therefore, they have the same area. So if we should call this circle 1 and circle 2, so A1 plus A2, right, will be equal to 8 pi times 2, because both of them should have the same area since both of them are equal. And this will give us 16 pi. Now I want you to look closely, okay? I want you to look closely. So I can now write that the sum of the area of the half circles is 16 pi. Now, if you notice, you will see that this is equal to the sum of the quarter circle. So it's the same thing as the area of the quarter circle. So if the quarter circle's area, which is 16 pi, is equal to the area of these two semicircles, then it is important to note that if that is the case, then this simply means that this area here is also equal to this area here. That is, this particular area is also equal to this particular area, right? Yes. All right, now we need to do something right now. Let us name the sides of this quarter circle. So if we call this place 1, okay, so I'm cleaning this because we know already. So if this is 1, this is 2, this is 3, and this is 4. What this means is that the area A1 should be equal to A4. All right? Yeah, A1 should be equal to A4. Now, this is what I want us to pay attention to. If you join this to this, remember that this is not drawn to scale. So when I join this to this, this is supposed to just touch this like this. It's not supposed to go over. All right, permit me to clean this and make it neater so that you will understand what I'm doing. All right, so this is the circle, the center of the circle. So this is supposed to come like this. All right, yeah, it's supposed to have something like this. Remember that this is not drawn to scale. You can actually pick your protractor and construct the circle. You're going to see the same thing. All right, now if we look at what we have here now, you can see that from here to here, this is a quarter circle, right? This is a quarter circle. That means this is 4, and from here to here is also 4. And if we decide to divide this into 2 equal parts by drawing a straight line through it, all right? So we are going to have something like this, we have something like this anyways, but we are taking half of it like this. Okay, yeah, so this is 4 and this is 4 as well. Now you can see that what we have here now is a sector of a circle that is the theta is equal to 90 degrees. Now area of a sector is equal to theta over 360 times pi r squared. Theta over 360 times pi r squared. Now in this case, our theta is 90 degrees. Okay, so we have 90 over 360 times pi times the radius is 4. 4 times 4, right? Yes. Now 90 we divide itself 1. If we divide 360, we have 4, right? And 4 we remove 4. Therefore area of this sector now is equal to 4 pi. Okay, so the area of the whole of this now is 4 pi. Now there's a triangle inside here. This triangle now, this triangle, so this is 90 degrees, right? This is 4, this is 4. Now this triangle, area of this triangle is equal to half base times height. Okay, is equal to half base times height. So this should be equal to, so this area of the sector, let me write it somewhere. So area of sector is equal to 4 pi. So area of triangle is equal to, that is what we are trying to find. Okay, so the area of the triangle is pi half base times height. So in this case, this is equal to half times, now the base is what? 4. The height is also 4. When 2 divide itself 1, if we divide 4, we have 2. 2 times 4 is 8. So it means that the area of this triangle is 8. Now, if we want to find parts of the area of this particular shape here, so if we should remove the area of the triangle from the area of the sector, so area of the triangle minus area of, area of the sector minus area of the triangle, so that we get part of this side. So area of the sector minus area of the triangle. So this will give us, this is equal to 4 pi minus 8. So if we do that, if we take away this from the whole of this, all right, that means we'll be having part of this, right? Yeah, and this is half of the whole of this. So it means that the whole of this shape now should be equal to, the area should be 2, that is A1. Remember that this place is our 1, right? So it means that A1 will be equal to 2 times 4 pi minus 8. So this implies that A1 is equal to, this should be 8 pi minus 16. 8 pi minus 16. That is our A1. Now, we have gotten our solution already since we have found our A1. So it means that the whole of this, everything inside here, is equal to 8 pi minus 16, right? So, and remember, so now we have that A1 is equal to 8 pi minus 16. But recall that A1 is equal to A4, right? This place is equal to the whole of this place. Okay? So it means that if we want to find the area of the shaded portion, area of all the shaded portion, it should be equal to 2 brackets 8 pi minus 16. 2 times 8, 16. 2 times 16, 32. So you can use your calculator to find your answer in decimal. Thank you so much for watching, and I wish to see you in my next video. Bye.